All right, so like I was saying, let us continue from where we ended. So I said in the x, we have the vector, we're trying to find the position vector r, a, b. So meaning we're coming from what? From a there to b. So if we're coming from a, in the x, we're just going to move along the positive what? The positive x. And how many units are those? 12. So we're just going to have 12 units in the x. And then in the y, I made a mistake in the previous video. I got z as y instead of y. So y is there. So for y, we know that the positive y is this side, meaning the 8 units that have been moved this side in the negative. So we move negative 8 units in the y. And then we also have now the z. We also now have the z axis. So in the z, we are going to move, in the z, we are moving the distance from there to that point. And then the distance from this point to that point is simply just 30 minus this 6 there, which gives us what? 24. But remember, we're coming from A going to B, which is under A. So the direction we're taking is this one, which is the negative what? Negative 30 minus 6. So 30 minus 6, that will give us what? 24. So the position vector AB is simply going to be 12i, negative 8j, then negative 24k. So this is the position vector in the direction of AB. So, we said RAB is equal to, we said 12i, then we found 8j, and then negative 24. Okay, so to find, the question is asking us to do what? The code represent the force acting on the support A as a Cartesian vector. So we want to represent 70 as a Cartesian vector. So how do we do that? We find the unit vector in the direction of AB. So how do we find the unit vector in the direction of AB? We find the magnitude of AB first. So the magnitude of AB will therefore be equal to the square root of 12 squared, 12 squared, then plus negative 8 squared plus negative 24 squared. So the magnitude of this position vector will therefore be equal to, so the magnitude is going to be equal to, okay, let me just use my calculator quickly. So we have 144 plus 64 plus 5, okay. So we have 144 plus 64 plus 24 squared. That is 784. Then the square root of answer. So we're getting 28. So the magnitude of this vector is 28 feet. So this 28, to find the unit vector in the direction of AB, find the unit vector in the direction of AB, we're going to divide the whole vector there. We're going to divide the whole vector by what? By the magnitude, because we know that to find the unit vector, we always divide the vector by its magnitude. So we divide the vector by its magnitude, and this is going to be 12 over 28 I plus, minus, sorry. So minus 8 over 28 j minus 24 over 28k. So once you do the divisions there, then to find the, to represent this force that you've been given in the direction, or to represent this force, as a Cartesian vector. You now just multiply the force times the unit vector. So when you multiply the force times its unit vector, or times the unit vector along the given line, the solution that you are going to get is simply just a Cartesian force. And this is going to be, so we have 70. 70 is going to be multiplied with everything there. So we have 12 over 28, I, then minus, so let me just do this. I don't know, let me just do it this way. Then we have minus 8 over 28J. Then we have minus 12 over 28K. So once you do the multiplication there, the solution that you're going to find is the solution for the Cartesian force that we're looking for. So the first one there, you have 12 divided by 28, and then you multiply it by 70, you are getting, so 12 divided by 28 times 70, we're getting 30i, and then we have 8 divided by 28 times 70, we're getting 20, so we have negative 20 J. Then we have 12 divided by 28, and then times 70. We also have another, oh sorry, this one is supposed to be 24, not 12. So we say 24 divided by 28, then times 70, so getting 60. So 60K. So this is also in pounds. So this is how you resolve any given force directed along a given line. So to find its direction, you can either find the unit vector of this force, or you can just use this same unit vector and find its cosine, angles. Yeah, so you can find its cosine angles and you get its direction. So this is what I was just trying to explain. Yeah, so you first find the magnitude. After finding the magnitude, you find the unit vector in the direction of the position vector. So the unit vector in the direction of the position vector. Then you multiply the force with the unit vector that you have found. And then after doing that, this is what you get. And after getting that, you simply now just get the unit vector that you found and find its cosine angles to find the direction this code that has been shown in the diagram. So to find the direction of this code in the X, Y, and Z axis, simply just take the cosine, the direction cosine angles of the unit vector. Okay, do you have any questions before we move on to the next question? Okay, so we proceed. What if you have two forces on the same plane, and then you've been asked to find the resultant of the two forces? So the first thing, like I told you, you first have to find the position vectors of these two given forces. So the first force that we're going to get, the position vectors along these given codes or cables. Yeah, so the position vector along the cable AC, the position vector along the cable AC is just going to be, so when you look at AC, so AC in the X, we're just moving from this point to that point. So from that point to, okay, let me start with AB. So AB, the position vector for AB is just going to be, so in the X, we're just moving from that point to that point, and this distance has been given to be 4. So we say this is 4i, and then in the Y, do we have anything in the Y for what's this, for AB? Remember, the Y-axis is this line. So this is the Y-axis. And if you look at the cable AB, it's just in the Z, meaning it's just in the Z. So for us to move from A to B, we just move in the Z and in the X. There is no need for us to move in the Y. So we don't have anything in the Y. So when we can just put a placeholder there, a value that is holding its the place of Y. So we put 0j. And then in the Z, we are moving from this point, from this point to that point. So this distance has been given to be 4 as well. So we also have another 4. But this 4 is going to be negative because we are moving towards the negative Z axis. Yeah, so this is going to be negative 4k. So after finding this, the next step is for us to find, in the next step, we're going to find the unit vector in the direction of AB. So how do you find the unit vector in the direction of AB? It's simple. You first have to find the magnitude of AB. So the magnitude of the position vector AB is simply just equal to the square root of 4 squared plus 0 squared and plus negative 4 squared. So after doing this, you can now find, so this is 16 plus 16, that will be 32. So the square root of 32 gives us something like 5.66. So the square root of 32, so this will give us what? 5.66. And this is the magnitude. So we're using meters. So this is the magnitude or the length of what? Of the cable AB. So we have found RAB. We have found RAB, and we've also found its magnitude, which is 5.66. So to find its unit vector, so the unit vector along the cable AB is simply just found by finding, dividing the position vector AB by its magnitude. So when you divide the position vector by its magnitude, the position vector that we have is 4i negative 4k. Then when you divide everything by the magnitude, which is 5.66, we are going to get, when we divide 4 by 5.66, we're getting 0.707. So we have 0.707 meters. So this is what we have. Oh, sorry. This is the unit vector we're finding. So this will be I there. Then we also have minus 0.707 J. Oh, sorry, K, not J. We don't have anything in J. So that is what we have. So this is the position, this is the unit vector in the direction of AB. So to find the Cartesian force, or to express this force in to represent it in the in Cartesian or in the ij notation, we simply just multiply it with the unit vector. So the force AB will therefore be equal to, we multiply that 100 newtons by 0.707 minus 0.707 K. Then here we have I. So when you do the multiplication there, you get 70.70 or 70.7. So the force in the direction of AB The first one here will get 70.1, oh sorry, 70.71 I, then minus another 70.71 K. So this is what you have as the force directed along this cable. Yeah, so let us also do the same with the force AC. We first find the unit vector. We first find the position vector along the line or along the cable AC. So how do we find the position vector? So we have rAC. So rAC here rAC here is from this point. Let me just erase everything so that you follow it up bit by bit. So we're moving from A to C. So if we're moving from A to C, in the X, we're just going to move from that point, so which is just the same as starting from that point up to that point. So it means that we're moving how many units? 4 units. So we're moving 4 units in the X. Then in the Y, we are moving from that point to that point. That is in the y-axis in the Y. So in the Y, we're moving also in the y-axis in the positive direction of Y by how many units? By 2 units. And then in the Z, we are moving from there to there. So we're also moving 4 units in the Z, but of course in the what? In the negative Z. So we're moving like this. To come to this point from A to C, we have to move in the Z 4 units, and then in the X 4 units, and then in the in the Y we move 2 units. Okay, so to find this is the position vector of the cable AC. So after finding the position vector, we need to find its magnitude. The magnitude is important because it's going to help us to find the unit vector along the cable AC. So the magnitude of rAC, is simply just the square root of 4 squared plus 2 squared minus plus negative 4 squared. So this is now going to be, so we have 16 plus 16, that is 32, plus 4, that is 40. So we have the square root of 40, which is 6.3. So we have something like 6.32 as the magnitude of RC. So in case they ask you to find the length of this cable, this is the length of the cable. So now, having found the length, we are now going to divide this same magnitude into the position vector so that we can find its unit vector. So how do we do that? So we're going to say, to find the unit vector, vector of RAB, we simply just divide the vector that we have found, which is vector, oh, sorry, not RAB, but RAC. We simply just divide the vector RAC by its magnitude. So the magnitude of AC has been found. So we divide 4i plus 2j minus 4k. We divide everything by 6.32. So when we divide everything by 6.32, we are going to get the unit vector in the direction of AC as, so the first one there will be 4 divided by 6.32. So we are going to get we're going to get 0.632. And this will be I don't know if I can write it just down there. So let me just write it down. So the position, the unit vector in the direction of AC, the unit vector in the direction of AC is simply just going to be, so when you divide that by 6.32, we're getting 0.63 as the first the x value, and then we divide 2 by 6.32, we are getting 0.316. So we have plus 0.31. Okay, let me just say 0.32. Then we have J. Then we also divide -4 by that, which will also give us 0.63 K. So to find the force directed along this same cable here, in Cartesian form, we have to multiply the force that we have been given there by its position vector. So if we multiply this by the force, which is 120, whatever that we're going to get is our force in Cartesian. So we are trying to look for the resultant force acting on the, acting at A. So we're trying to find the resultant force acting at A, which we expect to be somewhere there. So how do we do that? So it's easy. We first have to express these forces in Cartesian, and then we add them to find the resultant. So the force for this one, we're going to multiply 0.63 times 120. So 0.63 times 120, we have 75.6. So the first value there, we have 75.6 I, and then we have plus. We also have 0.32 times 120. So the 120 is simply just this force that we've been given there. So we have 38.4 J. Then we have minus 0.63 times 120. This gives us 75.6 as well. So we have 75.6. So of course, they're supposed to be K this side. So this is the force that we have along the cable AC. So now to find the resultant force, we simply just add the forces along AB and the force along AC. So what this means is that we're going to add the ones that have I together. So this one and that one, the ones with J together and the ones with K together. Okay. So we can begin to add. So if we add 75 and that, we're going to get, I don't know. Okay, let me just display the solutions. I think I also included the solutions. So this is what I was talking about. To find, you first have to find the position vector in the direction of AB, find its magnitude, and then find its unit vector, and then afterwards multiply it by the force that you've been given. So the solution would be that, and this is what we found. Then from there, you also do the same for the second part. So for AC, you also find the position vector along AC. The position vector AC, then you find its magnitude. So I think, I don't know where I just made a mistake. I think it's when finding the magnitude, because 4 squared and 4 squared gives us 32. 32 plus 2, it gives us 36, meaning the square root of 36 gives us 6. So I think I made a mistake when finding the magnitude. Yeah, so from there, we just multiply 120 times everything there. Times the position vector, and then you get something like this as your solution. All right, so this is exactly what you are supposed to do. And then to find the resultant. The resultant is simply just found by adding the corresponding terms in this vector AC and vector AB. So you add 70.7 to 80, which will give you something like, is it 8? Rather, to give you something like, it should be 150.7, something like that. Then you also add 40 plus 0. We don't have anything in the J here in the y-axis, so we add it to 0. So just remain with 40. Then you also had negative 80 and negative 70, which gives you 151 point something. 150 point something. So this is what I was just talking about. So once you do the addition, then you get your solution like that. So the only mistake I made was I just miscalculated here to find the magnitude of RC. Otherwise, the procedure is 100% correct. All right, so I think this is where we're ending tonight. Yeah, so this is where we're going to end tonight. So if you have any questions, feel free to ask. So since you don't have questions, I have questions for you. There is this exercise which you have to do. So I'm going to post the slide in the group, and make sure that you go through the slide and also the video and see where you didn't understand. Then from there, you have to answer the exercises. We have question 1 and question 2. So these questions are almost the same as what I was just solving. They are not that different. So you just need to find the position vectors and everything, depending on what the question is asking you to do. All right, so thank you very much for attending tonight's lesson. If you have any questions, feel free to contact me using these lines on the screen, and we are going to help each other that way. All right, so see you in the next lesson. My name is Untitled.